into the pure mem decompile. This time we don't have such a long path to go along. You see it's named a bit funny because that's how it comes out in the namespace. But we still get a fairly decent decompiler, and that's purely from the object. So we haven't touched disk at all. This is just from something that was available in runtime, and we've got a pretty good enough to find bugs with decompilation. That's about as exciting. I haven't got any time to show like the core graphing or the calling out to the extra functionality. So conclusions. Obviously, the development and distribution landscape are changing. We need to evolve to make sure that our work and reversing and finding bugs maintains a decent ROI, that we don't have to spend a year looking at something before we can get a good bug. Higher level languages actually give you a very rapid return on investment just because it's an area that many people have looked into. There are Python reverse engineering techniques. We've had a little bit of a taxonomy across them. If we, as a general rule, go from a static decompilation into in-memory, we get some good advantages, some drawbacks, but I think those drawbacks are outweighed by the advantages that we get. And pyREtic is kind of proof of concept for people to begin playing around with the in-memory decompilation stuff, rather than like a commercial tool. Kind of take it and have a play with it. So with that, are there any questions?
What kind of feature?
Oh, you and then you.
What kind of feature are you looking at taking it into attack live, or what's kind of?
So taking it into attack live.
Yeah, like you get in there, play with it live, or just pull it down for decompilation.
At the moment, it's purely been based on grabbing the source code, analyze offline, and then attack afterwards. Obviously, there's getting in process to a Python service, and then doing like cool things like swapping out code objects for other code objects. They're supposed to be immutable, but if the code object doesn't get refreshed, there are ways to swap it out. So you could essentially Trojan in memory the Python objects. It would look good on disk. All of those are interesting areas, not really what pyREtic's looking at, but certainly areas that I'm looking at. So I'll speak to about next year. And the guy.
At the end of the first half of the demo, there was a thing in big capital letters that said opcode remap mismatch. What caused that?
The opcode remap mismatch is when if the bytecode produced in the PYBs doesn't quite match up. So obviously, I've just got some simple logic saying, read a byte. Is the byte the same or different? Is the value of that byte one that looks like it should have arguments, yes or no? So it's you would have seen it said 100 opcodes remapped. So there's like 13 opcodes missing. That could be because the opcode, the bytecode that we generated, those opcodes weren't actually generated within that bytecode stream. But it's a good question. It's something that I'm working on that wasn't ready for today. Is rather than going over the standard libraries like we were and colliding them, just having one Python file that generates all of the known opcodes. So you just compile that in the obfuscated, compile it in the regular, and then you'll get every opcode, so you get 100% completion every time. That's something, you shouldn't be too hard, I just haven't had time to do it, but that's where it will be going. It will mean a lot less processing and a lot less work. Anybody else? Oh.
Do you expect that the vendor will generally release, if they release a custom interpreter, they will release a custom compiler?
So the compilation is more really in the marshalling. They will often affect the compile.c as well, but they have to undo all that to get it back into a memory object. So almost I don't really care what they're doing with their compilation, because once it's compiled, it goes into a standard object and they have to access it back out anyway. If I can access it in a Python namespace, they can be as funky as they like in the compilation, but they've got it into a runtime object, and I'll just introspect that because that will be a standard runtime object. I mean, they could go further and then start to essentially rewrite Python, but then that's outweighing all the advantages that they went to using Python 4 anyway. So I don't think they'll ever go too far on doing too much. I think they're just putting enough barriers in place to stop people just taking a standard PYC and reversing it back out. Okay, thank you very much.